Okay, everybody, welcome to lesson 6E, solve problems with the quadratic formula, using quadratic equations, chapter 6.5. Now, speaking of the quadratic formula, I do want to address a few things from last week's lesson, or last lesson, I should say. Now, there are some issues, and there's one thing I never mentioned, and that was, I left it on purpose, thinking that the quadratic formula was so new, I didn't want to include something else as well. But in hindsight, it's not necessarily something new. It's just a special name for a section of the quadratic formula and why it's important. And I'm just going to rewrite the quadratic formula quickly. Okay, now, that piece is this piece right here. Inside the square root is this b squared minus 4ac, part of the quadratic formula, and this is called the discriminant. And why do I care about the discriminant? Well, I care because some of you ran into an issue when you were using the quadratic formula. Well, it should have been all of you, but some of you ran into an issue when using the quadratic formula. And that was because you ended up with either a negative here or a 0 here. And you started asking questions. Well, what does that mean? Well, before we even dive into that, let's think for a second. Can I have a square root of a negative number? Let's say negative 8. Or even negative 9, let's say. Negative 9. Is that possible? No. Why? Because you got to think back to what does a square root mean? What does it imply? If I have a square root 9, positive 9, this means is either 3 times 3, so something times itself, so a positive 3 times positive 3, or it could be negative 3 times negative 3, right? Something times itself, so a negative and a negative. Now, if I had a negative number, I need to find a square root of a negative. I need to find a number such that if it multiplies by itself, it will give me negative 9. But how is that possible? Because in both cases, 2 negatives give me a positive, 2 positives give me a positive. So I need to multiply something by itself to give me a negative, but that won't be possible. Because whatever the number is, let's say it's a positive 3, itself would be, again, a positive 3. Both signs would be the same, I'll end up with a positive. If it was a negative 3 and multiplied by itself, it would still be a negative 3. And 2 negatives will also give me a positive. Okay? So it would be impossible to find the square root of a negative number. Now let's go back to this for a second. So why does that matter? That matters because if my discriminant b squared minus 4ac is less than 0, that means it's a negative. And since you can't square root a negative, that would imply there are no x-intercepts. Okay? So let's use this question as an example. Okay? So the b squared would be negative 1, because there should be a 1 there. So that should be negative 1 squared minus 4a. A value is negative 2. C is negative 1. Okay? And what does that give me? Well, 1 squared. So negative 4 times negative 2 is positive 8. Positive 8 times negative 1 is negative 8. So I'll get a 1 minus 8, which will give me negative 7, which is less than 0. Okay? Which means for this equation, there are no x-intercepts. So without x-intercepts, well, let's check to see if that's true. And sure enough, I've already graphed it. Y equals negative 2x squared minus x minus 1. And does it cross the x-axis? It does not. Okay. Now the other scenario is, what happens when b squared minus 4ac is equal to 0? Well, if it's equal to 0, let's think about this for a second. If this was 0, what's the square root of 0? The square root of 0 is just 0. That means my two x-intercepts would be this. Negative b plus 0 divided by 2a, and or negative b minus 0 divided by 2a. Well, in both cases, whether you add 0 or subtract 0, wouldn't you end up with the same thing? Which means you only have 1 x-intercept. Okay, because both of these are the same value. And of course, the last one, which is the most common, if it's bigger than 0, you have 2 x-intercepts. Okay. Now, how does that relate to today's lesson? In some of these questions, we'll be looking for either 0, 1, or 2 solutions. Okay. It won't ask you explicitly, but you can use that to kind of help analyze whether you need 0 solutions, 1 solution, or 2 solutions. Okay. Alright, so let's start. Solve problems using quadratic equations. So another thing about this chapter is that it wraps up all of quadratics. So chapter 4, 5, and 6 kind of culminates here. Solving problems, whether graphically or word problems, using quadratic equations. And if I really had to summarize the big picture, it boils down to one of two things. Either I'm finding the vertex, which is going to be the highest or lowest, which means I need to complete the square. Or I'm finding the x-intercepts, whether there's 2 x-intercepts or 1 x-intercept, or of course no x-intercepts. So it's either finding x-intercepts or the vertex. So let's go. A firework is launched upward at an initial velocity of 49 meters per second from a height of 1.5 meters above the ground. The height of the firework in meters after t seconds is modeled by this equation. What is the max height of the firework above the ground? So before, even if I understood none of this question, I should immediately catch the fact that we're being asked to find the maximum height, which should immediately tell you that you need to find the vertex. So if you need to find the vertex, you need to complete the square. Complete the square. Okay? So let's go. So height equals negative 4.9 t squared. I'm just copying down the question. Plus 49t plus 1.5. Okay? Now, I'm going to factor out the leading coefficient between these two. So that means I'm going to take out the negative 4.9, and inside the bracket I'll have t squared. Now what's 49 divided by negative 4.9? 49 divided by negative 4.9, if you type it in your calculator, you'll get negative 10t. I'll leave a bunch of space here, plus 1.5. Okay. Now, what goes in here? Plus, minus, the square of half of that. So plus 5 squared minus 5 squared. Okay? And now, to put this into vertex form, I know that it's going to be negative 4.9 t. Copy down that sign. And square root of 5 squared minus 5 squared. And, of course, I need to free out the second. So second negative 5 squared. So 5 squared is 25. Negative 25 times negative 4.9 is, so negative 4.9 times negative 25 is positive 122.5. And then, of course, I'm going to add the plus 1.5. And I'm just going to rewrite this. T minus 5 squared, and then 122.5 plus 1.5 is 124. Okay? So which means my vertex is 5 and 124. Therefore, the max height is 124 meters. Now, it didn't ask here, but if it did, what if it asked, what is the horizontal distance to reach this maximum height? You would say it's 5 meters. Okay. This next question is tricky. Okay, it stumps most students because of the wording. So let's make sense of this. When in doubt, draw a picture. Over what time interval is the height of the firework greater than 100 meters above the ground? Well, we know the highest height, or the highest point of this firework, is going to be 124. So it's asking how long does it spend being up higher than 100 meters in the sky. So let's draw a quick picture. So I know that the y-intercept is negative or positive 1.5, and I know the vertex is at 5 and 124. So vertex is 5, 1, 2, 4. Okay. Now again, I see the a value is a negative, so I know it's facing downwards, which means that it's going to go through the vertex, or sorry, go to the y-intercept, hit the vertex, come back down. Okay. So the question is asking, let's pretend that's 100, because we know 124 is about right there-ish. Okay. So it's asking, how much time does it spend in this section above 100 meters in the sky? Well, to figure that out, I need to find, well, at what time, let me just move this down a little bit. At what time is it even at 100 meters? Well, if I could find out what time this is, and then find out what time this is, wouldn't that tell me the interval in which this is above 100 meters? It sure would. So for example, let's say I solve for this and I find the time is 1 in this case. So at 1 second, it is at 100 meters. And then I find at 3 seconds, it is again at 100 meters. So that means between 1 and 3 seconds, it is spending, the firework is above 100 meters in the sky. Question is, how do we find those times? Well, I know, do I have a formula for the height of this firework? I sure do. So the height of this firework is h equals negative 4.9 t squared plus 49t plus 1.5. And this is taken directly from the equation. And what is the height we're trying to find? Well, the height we're trying to find is at 100. So 100 will equal to all of this. I'm sorry. I don't know why it glitches like that. Probably not a big deal, but I find that this really helps with explaining this question. Okay, so the height, we want it to be at 100 meters, okay? Now, equals the rest of the equation. Okay? Now all we have to do is solve. Now we're not solving for a max height or minimum height, we're trying to solve for t. So since we're trying to solve for t, that means we either need to factor or use the quadratic formula. Okay? So I'm going to move the 100 to the other side, which gives me negative 4.9t squared plus 49t plus 1.5 minus 100. Oh. You know what? We're just going to deal with that. Minus 100. Okay? I don't know why the whole thing turned pink. Now, so then I get negative 4.9 t squared plus 49t. And then what is 1.5 minus 100? Negative 98.5. So once we are here, our job is to solve for t. Now, I'm looking at that thinking, am I even going to try or attempt to factor that? Probably not the greatest idea. So I'm not going to. I'm going to use, if I can't factor, what's my only other option? The quadratic formula. So instead of x equals, it's t equals, because that's what we're trying to find, right? So t will equal to negative b plus minus square root b squared minus 4ac divided by 2a. So I can take the time to check b squared minus 4ac to see if there's one or two solutions. But visually speaking, we know we're going to get two solutions, and I might as well just solve it knowing that there's going to be two solutions. So negative b, so b, remember my a value, my b value, and my c value. Now, just so we don't get confused, the a value is just the coefficient that's there. The b value is just this coefficient that's there. And the c value is just that constant. Okay? So then negative b would be negative 49 plus minus b was 49. 49 squared minus 4a is negative 4.9. And my c value is negative 98.5. Divide this whole thing by 2 times negative 4.9. Okay? So then that gives me negative 49 plus minus. Okay, so using BEDMAS, 49 squared, I can't really do anything to that right now. I'm going to multiply negative 4 times negative 4.9 times negative 98.5 to see what I get. So negative 4 times negative 4.9 times negative 98.5 will give me negative 930.5 divided by 2 times negative 4.9 is negative 9.8. Okay? Almost done. Equals negative 49 plus minus, let's solve that. 49 squared minus that number is 470.4 divided by negative 9.8. Okay? Now, that means our two answers are let's call it T1 is equal to negative 4 is it 4.9 or 49? 49, no. Negative 49 plus square root of 470.4 divided by negative 9.8 equals, so if I could probably type all that in my calculator at the same time. So negative 49 plus square root of 470.4 equals divided by negative 9.8. So I'm looking at 2.7, let's say 79. And our second time would be negative 49 minus 470.4, square root of 470.4, divided by negative 9.8 will equal to, let's see, negative 49 minus square root of 470.4 divided by negative 9.8 will give me 7.21. Okay, so what does that mean? Let's scroll up. That means our first time is going to be, let's make the screen a little bit smaller. Okay. So what does that mean? That means that our first time, this time right here, would be 2.79, and then this time here would be 7.21. So therefore, the firework will be above 100 meters between 2.79 and 7.21 seconds. Okay, now let's see if that even makes intuitive sense. Well, I know that for a fact at 5 seconds is when it hits the highest, right? So between 5 and 0, this is a 2.79, that makes perfect sense. Okay, so it hits the max at 5, it's 5 seconds, a max of 124. Now it's the second times at 7.21, which is slightly higher than 5. That makes perfect sense. Now if I want to check my answers, I can surely open up Desmos. Y equals negative 4.9 I'm going to use x squared plus 49x plus 1.5. Okay, so the scale is probably a little bit off. Let me just adjust the scale. So x-axis, maybe I want it from negative 5 to 12, y from negative 2 to 150. Okay, so let's see if this makes sense. My max of 5, 124? Yep, 5, 124. Now, I want to see where, so I'm going to put y equals 100. This firework gets launched from a height of 1.5 meters, goes up, and I want to find out at what times will this be above 100. Well, the times are between 2.78, 2.79 to 7.213. 2.79, 7.213. Okay? Awesome. So this question was tricky. A lot of these other questions are similar, but it's all in the wording. Okay? It's all in the wording. So some of these, I'm going to set them up for you, but I'm not going to fully solve it. It's up to you to decide how you use, whether you use the quadratic formula, factor, or complete the square to find the vertex. So number 2, a rectangular park measures 100 meters by 60 meters. A path of constant width needs to be paved around the perimeter. The mayor wants to be sure that the path does not reduce the grass by more than 10%. What is the maximum allowable width of the path? So we want to create a path all the way around in the perimeter. Okay? And I know that that distance is going to be x, because we want a constant width. And that distance is also going to be x. Okay? Now, we do not want to reduce this by more than, this will still be the park. Originally, the red represented the entire park. But we want to pave a sidewalk around it, or some kind of path around it, so that the park doesn't lose, the area does not drop by more than 10%. So in other words, we still want to maintain 90% of the park. Okay, so what does that mean? Well, the original area, let me just use red. The original area is 100 times 60, right? Which will give me 6,000. 6,000 meters, I think we're talking here. 6,000 meters square. Yep, okay. Now, we want to maintain, we do not want to lose the area. The path does not reduce the area of the grass by more than 10%. So, which means we still want the area to be 90% of 6,000. Okay? So that should give me 5,400. Okay, so which means the area of this should be about 5,400. Okay, so what is the maximum allowable width of the path? Well, we need to look at this and think, okay, well, what should be my new width then, or length? So my new length would be 100. Originally was 100. And that's going to also be x. 100. In fact, I'm going to make that red so you can see where the 100 came from. So my original was 100. Now, I'm going to take away, because I'm cutting both sides, I'm cutting this little width section, cutting that section, and I'm also cutting that section, which means I'm taking away 2 x's, okay? Because this is going to be a constant width around, or constant path around, I should say, of constant width. So this is x, so I'm removing an x from this side, I'm removing an x from this side, so the new length of this would be 100 minus 2x, okay? And then, what would be this side? Well, this side would be the same thing, except it would be 60 meters, and again, I'm removing the same amounts from both sides, so this width the width of this path will also be x. So I'm removing a section of x here and a section here, okay? Which means the width of my new park would be 60 minus 2x. Okay? So if I redrew this, so I'm going to draw this out so that maybe it's a little clearer. So the dimensions of my new park without the paved would be 100 minus 2x, and then this would be 60 minus 2x. Okay? Well, what is the area of this new park? What does the area of this new park have to be? 5,400. So all this we need to equal to 5,400. Okay? And then from here, our job is to solve this. So to solve this, multiply that out, okay? And then move the 5,400 to the other side, and solve for x using quadratic formula. So solve for x using the quad formula. Okay, I don't think you'll be able to factor this one. Okay, question 3. The length of a rectangle is 16 centimeters greater than its width. So let's say that's the width. Oh, I think I forgot something here. I forgot a let statement. Always include a let statement. So, because I see x's everywhere, well, what do the x's mean? You should probably include this at the very beginning. But since I forgot, I'm just going to throw it up here. Let x represent the width of the path. Width of the path. Okay? So, question 3. The length of a rectangle is 16 centimeters greater than its width. So the length there will be 16 plus x. Well, what does x represent? So let x represent the width. Okay? Now we know the area is 35. So length times width, so we got 16 plus x, length times width, will equal to 35 meters squared. Now let's expand this in. So again, we are asked to find x. So if that's the case, we can factor or use the quadratic formula. So 16x plus x squared equals to 35. And then move them things around. So x squared plus 16x, move to 35, minus 35 equals to 0. Okay, and then we can look at this and go, oh, this could be common fact or simple factoring. Two numbers that multiply to give me 35, but at the same time, let's add to give me 6. 7 times 5? No. How about... No, I can't think of anything. So if that's the case, use quadratic formula. Okay? Now, remember, all of these are quadratic equations that model quadratic behavior. So I could, if I feel like cheating a little bit, I can look at that and go, oh, it looks like I could simple factor it, but I can't find those numbers. So what I'm going to do is use Desmos. So I'm going to sketch that. And I'm going to go back and realize I typed it in wrong. This should be minus 35. Okay, so which means my two values are going to be this, 3.633 and negative 9.6. So in the context of this question, negative 9 and negative width makes no sense. So I know the answer is going to be 3.633. In fact, you can check. 3.333, or sorry, what was it? 3.633. That means the two sides will be, length will be 3.63, and the width, or sorry, the width would be 3.633, and the length would be 16 plus that, so it would be 19.633. Sorry, I think I typed something wrong here. Oh yeah, I did. Let's backtrack. That doesn't make sense, because 19 times 3 won't give me 35. So I realized that's supposed to be a 16. And then 7 times 5 still wouldn't work, would it? Nope. So let's just go back to decimals quickly, and let's throw a 16 in there. There we go. Those are our two values. 1.95 or negative 17. Again, negative 17 wouldn't make sense. Let's try 1.95. So the two values would be 1.95 and 17.95, because 16 plus 1.95 is 17.95. So if you multiply length times width, so 1.95 times 17.95, you should get 35. Okay? Alright. Let's take a look at the next one. The product of two consecutive numbers is 36. Consecutive means one after another. So we'll let x represent a number, which means I have x, and then what is the consecutive number? Well, it's just one higher, right? So x plus 1 is equal to 3306. What are the numbers? Again, I can expand, move the 3306 to the other side, and either try to factor or use the quadratic formula. Now, if you really want to check the answers right away, you could go into decimals, and you have x plus 1 equals 3306. And let's just zoom out so I can hopefully see the graph. Okay. Which means the values are either negative 58, which means the two numbers will be negative 58, and then what's negative 58 plus 1? Negative 57. So negative 58 times negative 57 will give me 3306. That would be the answer. Or it could be 57, positive 57, and 57 plus 1 is 58. So 57 and 58 will also give me 3306. Obviously, I'm not trying to convince you to cheat. I'm convincing you to make the connection between these equations and its respective graph. Okay? Of course, I would prefer if you expand that out to get x squared plus x, move this over to get negative 3306 equals to 0, and factor, or use the quadratic formula. Okay? Next question. The length of one leg of a triangle is 7 centimeters more than the other leg. So, let's call that x. Let x represent one leg of triangle. Okay? The length of one leg of a triangle is 7 centimeters more than the other leg. So I know this one will be 7 centimeters more. The length of the hypotenuse is 3 centimeters more. So I know it's 3 centimeters more than double of the shorter leg. Well, which one of these is shorter? Obviously this one. So double of that. Find the length. So in other words, I have to solve for x. Okay? Well, right triangle, 90 degrees, I can use Pythagoras. A squared plus b squared equals c squared, which means I have x squared plus x plus 7 squared equals 2x plus 3 squared. This one will really test your algebra skills because you need to expand everything. But this does not equal x squared plus 49. Does not. This means x plus 7 times x plus 7 equals 2x plus 3 times 2x plus 3. Okay? And then I'm going to expand this out. So x squared plus 7x plus 7x plus 49. And then, again, factor or use quadratic formula. Or quad formula. Okay? So the rest of these are pretty similar. The cylindrical can with a height of 12 centimeters So cylindrical can, 12 centimeters, has a capacity of 600 milliliters. What is its radius to the nearest meter? Capacity, so we're assuming volume. So volume equals pi r squared times height. Okay, so we know the height is volume equals pi r squared times 12. And we also know that the volume is 600 milliliters equals pi r squared times 12. So in this case, we could either, I'm looking at this and I see there's only one variable now, just r. So yes, you can just simply solve for r, and you found the radius, you're done. Or you could move the 600 to the other side, equals pi r squared, or I should just say 12 pi r squared minus 600, and you can also solve this with difference of squares. Okay, difference of squares, because here's a square. I don't know what the square of 600 is, but you can just go the square root of 12 pi. Okay. Now, it would probably, in a question like this, be easier just to solve for r directly. Number 7, the sum of two squares of two consecutive integers is the sum of the squares of two consecutive integers. So let x represent an integer. So they're consecutive. So one's x plus 1. Now we're looking at the squares of them though. So the squares, and the sum of them will equal to 365. Again, expand that, solve for x using factoring or quadratic formula. Okay. A rectangle has a perimeter of 23 centimeters. So if I know it has a perimeter of 23, okay, so I know this is its width, determine the dimensions of the rectangle, and its area is 33. So if I know that's the area, then, and I know that's the width, so let W rep width, then this side would be 33 divided by W. Okay, because length times width is 33. So if this is the width, so let's say that was 5, then 33 divided by 5 must be the length. And then to find the perimeter, it's just perimeter equals, well, W plus W. Add these up. So I will get 33 over W plus 33 over W plus 2W, because there's two of them there. And I know the perimeter is 23. Okay. Now you're probably wondering, but I have W's at the bottom. Well, what can I do? I can multiply every term by W times W times W times W times W, which will give me 20. So this is lagging a little bit. So 23W equals, these will cancel, 33 plus, these will cancel, 33 plus 2W squared. Okay, and then again, rearrange that and solve for W. Okay. So the next four questions are very similar. Okay, question 12. We've done a question like this in the past. If you have any questions about any of these remaining four, please post under math questions. Alright? Okay, take care.